Hi everyone, this is Andrea Howard. I'm an associate professor at Carleton University in Ottawa, and I'm really disappointed not to be doing this presentation live at SRA in San Diego, but we're going to make the best of things. I've got a couple of videos ready for you where we're going to learn a little bit about visualizing raw and fitted longitudinal data and some strategies I'd like to share with you from my own experience. We're going to be doing some demonstrations using R software inside the RStudio environment. So if you've got that software installed and ready to go, it'll be easier to follow along. We'll be working with an artificial data set that I created and based on this paper shown here. It was recently published in JAMA Pediatrics by Ping Chen and Kathleen Mullen-Harris using the complete AdHealth longitudinal data set. I've borrowed the public version and simulated a sample of 1,000 participants with waves spanning wave 1 to wave 4 and containing scores for depression and family cohesion in an attempt to mimic some of the findings that we see in this particular paper. So the artificial data that we're working with span ages 12 to 30 and are based on the public use files only. Before we dive into plotting longitudinal data, I'm going to give you a pretty basic orientation to our software and the ggplot2 package that we're going to be using for most of our plots. Basically, you don't need to know a whole lot here. You might not have been exposed to R before. I myself don't have a ton of exposure to it, and I've spent quite a bit of time really focusing on learning how to make good plots. Basically, we can take away that R is an object-oriented programming environment. So it's not a statistical software package per se, but it does do statistical analyses when we need it to. But everything that we're doing in R involves two steps. Step 1 involves giving an object a name, and step 2 involves telling the software what goes in that object. Right, so if I have an object I want to call X, I use this little symbol, the assignment operator, to tell it I want the number 1 to go in that object. So everything follows that basic format. Objects can be lots of things. They can be a single number like this. They can be a string of numbers or a string of characters, a whole variable, a whole data set, a plot, and more things. So let's switch over to R and try a couple of things to orient ourselves to the software. Okay, so if you've got R loaded up, you should have 4 panels in front of you. This one up here is my editor window. This is where I can type commands and ask to run them. This panel down here is my console window. This is sort of a peek at the actual R software and what's happening with it. Things like error messages will show up here, sometimes results. I've got a panel up here called the environment panel. This will show you any variables, any objects that you've created. And down here, we're going to be pretty interested in this. It's a panel where I can see various things, including help files, but most relevant to us, this is where plots will be rendered for us to look at. So let's try something really simple. We'll try making an object, that same one we saw in the slides. So if I want an object called X, I'll give it a name and assign it a value. So you can literally make that assignment operator using the kind of open-faced Pac-Man and a dash, or use one of the quick key commands. I'm on a Mac, so I can go Option dash to make an assignment operator. And I've told R I want the number 5 to be contained in the object X. So I can run this line by pressing Command Return, or if you're on a Mac, let's control return. So you can see what happened here. The environment shows me I have an object called X that has a value of 5, and the operation is also shown up in the console. That's easy enough. We can also make an object containing character strings. I'm going to call that object 3things. Assignment operator. So 3things gets what? I'm going to use the concatenation function here to group together a little list of 3 characters. So cat, comma, dog, comma, horse. Okay, we'll see that concatenation function a whole bunch. It's everywhere in R, really useful. But what we're doing here is telling the software that our object labeled 3things is a little list of these 3 character items. So I'm going to run that, control return. It can show up here in the environment. It's a character list or vector with 3 elements, cat, dog, and horse. And it's also shown up in the console. If I want to remind myself what's in one of my objects, I can just type its name and run just the name on a line by itself, and the console will spit out the answer. 3things is a little vector containing these 3 character elements. X does the same thing, returns the number 5. What we really want to do is load up our simulated add health data so we can start making some longitudinal plots. So there's a number of ways to go and get data. First, I'm assuming that you've saved the data files that I supplied online. A really simple way to go get your data that is similar to what you're used to in other programs is to start by giving your data a name. Right? It's an object. We have to put the data in that object. Use the assignment operator there. We're going to use read.csv. This is a built-in R function that will allow us to read CSV files. So we're going to use the file choose command. Okay, so I've said file equals file.choose, open close parentheses. And this is going to open up a file picker window, similar to what you would see in Microsoft Office or whatever. I can do that and go to my desktop. I've got it inside my SRA workshop folder, simaddhealth.csv. Okay. So just doing that like you normally would, it's produced a new object up here listed under data called sim data. And we've got all of these different variables inside. So if you've loaded a data file and you want to make sure it's the right one, you can use the view command. And this is going to open up a little data matrix, kind of like what you would expect to see if you're familiar with something like SPSS. So you can see it all and scroll through it. This is not an efficient way to look at your data, but it is a familiar one if you are new to a programming language. I'm going to do a couple of quick descriptive statistics on this data set just to orient ourselves. There's a lot of different ways to run descriptive statistics. And other kinds of statistical actions. We're going to do something called loading a package in R, install.packages. R is an interesting piece of software because it's sort of freely available, and just people out there in the community have written their own add-on packages that integrate with base R and that can be useful for a variety of purposes. So one group of folks wrote something called the Jamovi package, and it's nice for our newbies because it sort of spits out some output in a familiar, friendly format. So kind of eases us into the software. So if it's brand new to you, you're just starting to use R, you're going to have to install the package. Just literally this command. I've got command return here to install it. If you're connected to the internet, it's going to try and go find this software online for you. I think I already had this on my computer, so it's not needed to download everything. You only need to do this one time, but every time you start R all over again, when you're running new commands, starting up again for the day, you're going to need to load up a package with the library command. So I'm going to run that, and now the Jamovi package is accessible to me. So I'm going to just do some really simple descriptive statistics. So the command here is descriptives, and I'm going to tell it what data file, sim data, and I'm going to tell it what variable I want descriptive statistics for. And I'll just go with the longitudinal depression variable. So command return, and you can see in the console window I've got a nice little output here showing some basics for this variable. I can also do this with a number of variables at a time. Remember that concatenation function again? I'm going to tell it a few variables that I'd like to look at all in the same display: depth, age, and cohesion. So now I've got a 3-column table of descriptives. I can also do this to get a frequency table for a categorical variable, in this case cobin. So that's cohesion binned into zeros and ones, and I'm going to say frequency equals true. So that'll give me a little table of counts, percents, and so on for the 2 levels of cobin. Okay, so we'll be plotting our data in R using a package called ggplot2. This is a package designed by Hadley Wickham, who's a statistician and a current in-house scientist at our studio. It's not the only way to plot data in R. It just is extremely popular and a package that has a lot of flexibility, so you'll kind of see it everywhere. So the syntax is similar but unique in a number of ways. Remember that in R, a plot is just another kind of object, like a single number or a variable or a data set. But we're going to do a couple of things a little differently. So you still have to give your object a name, any name at all, my plot, for example. We use the assignment operator. But we have to invoke the ggplot function and then tell it a few sort of orienting facts about your data. And there's going to be a plus sign at the end and a new line followed by a plus sign for every additional layer of content that you want on your plot. So this can get quite large for complex plots, but in the end, when you want to render your plot, you do what we did before. We just type the name of the object on a single line and call it up, and it'll render the plot in our plot window for us. So here's a basic scatter plot. I've called it starter. So I'm going to invoke the ggplot package, and I need to tell it what data I'm working with. And in general, we will give ggplot some information about the what it refers to as the plot aesthetics. So what variable is going to be on the y-axis, what variable is going to be on the x-axis, in this case depression and age. And this information will be propagated through to any of our other commands in later lines. After the ggplot line, we have a geom function, in this case geom point, that will give us a scatter plot, so a scatter of dots on top of the plot. So there are lots of geom functions, and these are generally here to tell R what kind of plot to make. I've done a couple of things inside the parentheses of geom point. One is to use the position option to request jittered points. So if you have a lot of values that are similar or overlapping, you can see them a little more easily if you allow a bit of random jitter to the data. I've also included the alpha command to request a bit of transparency to the data points. So when there's a lot, it's nice to have them overlaid so that you can see through and get a better sense of how dense your data is. I also have a line for information about the y-axis, right, or the scale of my my y variable. It's continuous. It is called depression. I have a similar one for x called age, and I've used a built-in theme here to give some direction to what the overall plot is going to look like. I can control absolutely everything I want about the plot, including, whether to have a white background, a black background, or anything in between, whether to have this sort of cross-hatched backdrop for tick marks, whether to have a square around the plot or not, where the tick marks are located, the size of the font, whether there's a title, all kinds of things. There's lots of pre-made themes. And you can also custom edit your own. So let's try and make this plot ourselves. We'll go over to R now. Okay, so like I mentioned, ggplot is a package. So if you don't already have that installed in R for you, you're going to have to go ahead and get that. So install.packages, just like we saw before, with ggplot2 in quotations here. And we also need to load it up with a library statement so that we can have access to it. So let's try and make that plot we labeled starter from the slides. Okay, so the ggplot statement, tell it which data set we're working with. We provide the aesthetics. Plus, we need a new line here. We're going to get a scatter plot, geom point. And I want a position command to jitter the points. Position underscore jitter. And I'm going to make them a little bit transparent. Let's try 0.5. We'll also give some information about the scale. Call that y-axis depression. Remember, a plus sign after the end of every single one of these lines. And a theme. We'll just theme BW. It's pretty basic. I don't mind it. Okay. So now I can press Control Return again, and it hasn't rendered the plot yet, but it has run the commands. You can see that in the console window there. I need to, it's an object, so I need to type its name and run it on its own line if I want to find out what's in the object. Okay. So as expected, it's shown up over here in my plot window. We also get a bit of a warning about missing values. Some of that can be due to jittering if you've jittered some data outside of the range of your axes. And you may also just have missing data. In the case of this data, not everybody has a depression score at every single point. So You want to always be aware of what your missing data situation is and make sure that your plots are showing the data you're expecting. Okay, so there are a lot of really useful plots that you can make kind of at the data familiarization stage or the diagnostic stage. This is generally what I would consider pre-analysis. It's a really good idea to try and get a sense of what's going on in your data before you start imposing some kind of structure to it, trying to get trajectories and that sort of thing. So one pretty common one is a spaghetti plot. We don't tend to see these in manuscripts necessarily, but they can be useful for somebody who's getting a first look at their longitudinal data. This is kind of a longitudinal version of a scatter plot. So each person has a whole line rather than a single dot, and it'll span the waves that they contributed to the data set. Shows me a little bit about the intra-individual variability in my data, what kind of up and down movement I have. This one in particular really clarifies that the bulk of the data is below a score of 1 on the depression measure. And we have a sort of density peak here for higher depression scores in mid-adolescence, which is totally as expected. We can also see that high scores on the measure are relatively rare. You can also plot something like this for random subsets of your cases rather than the entire data set if, like this, you have a large number of participants. Okay, so we're going to make that spaghetti plot next, and I'm just going to draw your attention to the plot themes again. I have a theme that I've customized for myself, suits my personal preferences, and I've just typed it out here for you. And I'm going to use this this block of code literally cut and pasted to the bottom of all the plots to come. And you are free to do that as well, or to stick with a base theme, a built-in theme like theme BW. And this can also be a base for you to start experimenting with backgrounds that you would like to control in your own plots. Okay, so if I'm making the spaghetti plot, I got to give it a name, give that object a name. Okay, call it spaghetti. Again, I need the ggplot command and give it a data set, give it some aesthetics, same as before. Y is depression, X is age. I'm going to add a new command here. I need not geome point this time, but I need geome line. And we're going to give it an additional aesthetic. We're going to group those lines by ID, the variable ID. So that'll make sure that geome line produces a separate line for each unique value of ID rather than a single line that averages over everything in our data set. I'm also going to make the line a little bit transparent because there's a lot of them. We want to be able to see as many as we can. And then we've got to add our scale variables and our theme. So I'm just going to copy and paste those scale lines from our previous plot. Okay, a couple of modifications here. For scale Y, I'm going to specify where I want those tick marks. I'm going to tell it I want, well, the tick marks to be a sequence going from 0 to 3 by units of 0.5. And for age, it was, by default, we were seeing, like over here, it was in blocks of 5. That's not terribly useful. Instead, how about breaks going from sequence from 12 to 30 by units of 1. Okay. And then let's paste in this theme code here. So I'm going to make it look a little different. There's a plus sign at the end of each one of these lines as well. This first line rolls over. It's got a lot in it. Okay. Now if I run this spaghetti command, it's going to show up in my console. And again, if I want to render it, got to type it out and ask for it, run it here. Okay, so there's my spaghetti plot. It looks an awful lot like the one we just saw. Notice there are some theme differences here, right? The fonts are a little larger. I've got nice bolded labels for the X and Y axes, and the background is completely white. I still have a border box around the whole thing. Another kind of plot we can make that I think is really useful for visualizing raw data is something I call a traveling box plot. So this is, again, you're plotting all of your ages of data, and you're plotting individual points from your longitudinal data, but we're binning the ages into 1 year or otherwise groups and showing the uncertainty in those observations at each age. So from this example plot, you can see that I've got a distribution of observations at each age, and then a standard box with an interquartile range reflected at each age. And I've also overlaid a mean trend across the entire thing. So kind of have a number of sources of information here that can be useful for just visualizing the longitudinal trends that are present in the data, as well as getting a sense of how spread out it is at different time points. Here, what these box plots make clear is that the data really are skewed towards low levels of depression. So that was relatively evident from the spaghetti plot, but especially so here. So let's see how to make that plot. Okay, so this traveling box plot was a type of plot that has a number of layers on it, so we're really going to make use of the layering feature of ggplot. It starts with a scatter plot, so we can focus on making that layer first. Again, we're starting up, invoking ggplot, same data set, same set of aesthetics. Well, actually not quite, because we're going to switch to using the binned version of age. So in this data set, we had enough detail that people's ages could be measured to 2 decimal places, but that makes it difficult to sort of summarize information at each age. So there is a version of age also in the data set that rounds everybody's ages to their nearest integer. So we call that age bin, and we're going to use that one here. I'm going to go back to using geom point. And same thing we did before. We're going to jitter the data. And this time we're going to play a little bit with the exact positioning of that. So you can completely control the lateral sort of width of the jitter, how far apart those points are allowed to go side to side, and also up and down. So we can start with moving them a little bit side to side, 0.2, and a little bit up and down. These units are directly proportional to whatever you have on the y-axis. So this 0.2 is movement taking into consideration that depression goes from 0 to 3. Also, just like before, gonna make them slightly transparent, and just for fun, I'm going to make them a color. So you can search Google to find all sorts of lists of colors for ggplot. Are built-in colors, color names it'll recognize. This is just one among many, many choices. We use the same scale. In fact, I'm just even going to copy and paste it from up here. No need to redo that completely. So scale, Y, scale, X. nothing's changed there. And I'll also cut and paste my theme, a block of text that I've been using. Okay, so we can run this particular plot command. And again, it doesn't render a plot until we type its name and run that on a line. All right. So something to notice here with jittering is that the dots in some cases have been moved out of range of my scale. So I have a number of points here that are below 0 on the y-axis and also above 3, even though my scores only go between 0 and 3. So what's going to happen is your axis is going to adjust for that unless you force it to be limited. So something you can do is to add some limits. If you really don't want your dots to scatter all over the place and you're comfortable cutting things off, there's that concatenate function again. Limits equals C, and then I list a lower and an upper. So let's say 0 and 3. And rerun that code, ask Command Enter bin scatter again. So now you can see I've been restricted. I've also lost a lot more data points, as evident by the warning message below. So that may or may not be acceptable to you when you're plotting your data. So the scatter plot is just the base for a traveling box plot. We want to sort of layer that on top, right? We want to add our box plot over top of this sort of illustration of the variability we're observing in our data. So we can just literally copy and paste that whole code. I'm going to just take all of this, give it a new name. We'll call it travel. And edit this to include some new commands. Something to note is that I don't have to retype all of this. I can simply add a layer to an existing plot. But if you want to have full control over the order that different elements appear, sometimes it's nice. I like it from my perspective to contain all of the commands in a single plot. So I'm going to add, after geom point, add a new geom. It's exactly what you would expect, geom box plot. And if I say nothing else, I'm going to get a single box plot that'll sort of cover all of the ages at once. So just like we did for the line command, we need an aesthetic asking for those boxes to be grouped by a variable. And we're going to group it by age bin again. Okay. We can also control the width of our boxes. So just starting with 0.5. And we can control the transparency of our boxes as well. So I don't want them to be completely opaque. I do want to see a little bit of the dots underneath. So maybe 0.7. And I don't want to see any outliers in my box plot because they're already there. They're already, all of my observed data are present in the box plot. So outlier.shape equals NA will suppress the box plot geom print of additional outliers. I'm also going to go ahead and remove those limits on the scale there so I can see all of the dots at once. Okay. Let's see what happens when we run this new plot. Oops, I missed a plus here. There we go. Okay, now I've run the whole thing. Travel, name of the plot, Command Enter, and here we go. Okay, so looking pretty similar, but a little bit off from the version in the slides there, because I haven't cut off the base here, and there's no jittering on the box plots, so they don't quite line up perfectly. You might like the look of it better if we add back those limits on the Y scale. In fact, let's do that and see how this changes. So Y ranging from 0 to 3. So now my my scatter plot portion is incomplete, right? It's illustrative of variability, but it's not a faithful representation of all the data in your plot. But it does still give you a pretty good idea. So the additional layer of information that would be pretty useful to include here is an overlay of the means, right? We see the medians in each of these box plots, and they move around a little bit, but they're not exactly the same as plotting the means. And since our fitted models are generally going to focus on means, it's nice to see those as well. Unfortunately, we don't have means contained in the data set I provided, so that's something we need to calculate. That's pretty easy to do. Everybody knows how to get means. You're going to need a mean depression score for every age in order to stitch those together in a raw trajectory on top of these box plots. So we're going to need to calculate those first before we can overlay them. So this is also an opportunity for me to show you how to use another really useful package in R. Oops. This one's called dplyr. It does all kinds of useful things, one of which is to make some data manipulation steps a little easier. So you're going to want to install that if you don't already have it in R. And then whether you do or not, you're going to want to call it up after that point. Okay. So my console is telling me that that package is now ready to go. So I'm going to go ahead and make a new object. I'm going to call that depMeans. Remember, label the object, tell it what goes in the object. I'm going to make use of a simplifying tool that's part of the dplyr package that they refer to as a pipe. And it is simply a %, a little right pointing chevron, and another %. There is a quick key for typing that in on the Mac. It's just Shift Command M, yeah, Shift Command M. And the function of that pipe is to tell R, whatever is right before the pipe, I need you to feed it into the next thing. Okay, so it's a bit simplifying for a number of tools. So we're asking R to feed sim data, the object, the data set, into the next command, which is going to be a grouping command, group by age bin. So I want it to take that data, group it by age, and once it's done that, I'm going to need to feed that grouping structure into a new command, summarize, where we're going to make a variable that will produce a single mean for each of the ages. I'm going to give that variable a name, mdep equals, and it's going to contain the mean of my depression variable coming all the way over from sim data grouped by age. I'm going to tell it one more thing, which is NARM, or remove NAs, equals true. So it's not going to factor in those blanks into calculating my means. Okay, so these 3 lines should produce an object, depMeans, containing a set of means by age. And if I use that view command again to view the means, it should pop open a little data set here, containing 19 rows. I've got ages 12 to 29, actually 12 to 30, and a depression score for each of those ages. So I don't have to do anything interesting like integrate that data set back into my larger data set. Something really nice about ggplot is that I can use information from all different sorts of objects and just stack them on top of each other when I'm making a plot. So in this case, I'm reproducing my traveling box plot. This time I literally just copied and pasted it from the previous command. This time I'm going to call it with means. It's a new object, and I haven't changed anything so far in the code, but I do want to add 2 additional lines. After geom box plot, I'm going to want a line for my means. But here's where the general aesthetic from the ggplot command doesn't work for me. I don't actually want geom line to inherit any of this information, right? I want it to use the data from the dep means object I just created. So I'm going to actually have to tell it to pull from a new data set, data equals dep means, and I'm going to tell it what the aesthetics are for that particular data object. So now y is going to be mdep. X is also hbin, same name there. And I'm going to control the size of the line, make it a little thicker than default, and give it a color too. You can experiment. I'm going to use orange red here. Plus, need another line in here, also because I'm fond of connect the dots. I'm going to use geom point again on this new data set, so I'm not inheriting aesthetics from the general command. Use mdep and hbin, and I'm going to make those dots size equals 2 and the same color as the line. Make sure our pluses are at the end of each line. Okay, so nothing has changed about any of the other elements here. Okay, so if I run this command, I'll get another plot. It's been created, but here I'm going to render it, command enter. And now I've got a nice traveling box plot. You can make the decision to maybe trim age 30 from this plot. We know it was only based on a handful. I think there was half a dozen cases in here. So this isn't really giving me a good idea of what kind of variability I have out at this oldest age. It's starting to thin out around age 29, but age 30 is particularly sparse. Okay, the last kind of plot I'm going to illustrate for raw data is a kind of grouped scatter plot. So this is relevant if you have data where you're expecting more than one trajectory depending on some external factor, some time invariant covariate, for example. In the motivating example, the model was for trajectories of depression that varied based on level of family cohesion. So there we saw from that original plot that trajectories in families where there was low cohesion tended to be overall higher on depression compared to families with high cohesion. So this is an opportunity to use a bit of color differentiation in your plots and to overlay more than one mean. So here I'm just going to be modifying the scatter plot that we had been using for a traveling box plot to show a couple of different colors, and we'll overlay 2 sets of means instead of 1 set of means. So it's a really minor modification to what we've already seen. Okay, so we're gonna make another scatter plot now that has color differentiation by group. So I'm just copying and pasting the code from above that was for a single scatter plot, right, with binned age. And I'm just going to change the name of that plot to grouped. I'm going to get a new one. And we're going to do just a minor modification here. But before we do that, I want to just mention that once we're factoring in colors by some grouping variable, whether that's an ID and lots of values or two groups like this one, low and high, we have to incorporate those colors in some meaningful way. We have to be aware of what the defaults are, and we might want to control the colors to match some sort of aesthetic that is personally preferential. So I'm really fond of something called a Viridis group of color palettes. They are pretty attractive and perceptually optimized for people with color blindness. So if we want to make use of those colors, we need to install the package that they're situated in. So this is, they're just install packages Viridis. Right, so if you don't have that already, and then just like before, we're going to call it up. Okay. So the main adjustment to this plot here is going to be a change to our geom point line. First things first, I'm going to get rid of this general color statement because that would just color all the points the same. We want to color by group. We want to color by a variable. So we're going to need an aesthetic statement for that. If we want to modify something according to levels of some variable, that's normally going to go inside an aesthetic statement. So color equals, we have a variable in the data set called cobin, but it's not coded as a category variable, so we're going to coerce R into treating it as a category variable. Color equals factor cobin. Okay, so that is what's contained inside the aesthetic statement. We're still jittering those data points. We change the height jittering a little bit here and make them a little less transparent just to see how things change. Okay. We still use our scale commands here. I'm taking out those limits. So the theme's the same, scale, Y and X are the same. The difference is we're going to also add a scale statement that tells ggplot where to draw the colors from. So we need scale color. There's some built-in ones. You can see a list here, right? Scale color Viridis. And we have two options, right? C for continuous, D for discrete. We are using discrete in this case. Okay, we have two levels. The color palette ranges from a bright yellow to a dark purple, and you don't necessarily want the top and bottom colors of that list. You might want to choose from within. I personally preferred kind of to get more into the greens of this palette and to not get quite so far into the dark purple. So I'm changing the beginning and end points of where the package is drawing its color from. Goes from 0 to 1, and you can experiment with the values you put into begin and end statements until you end up with the colors you like. I'm also going to do something else here. NA translate. NA translate equals false. The reason I'm doing that is because without it, ggplot is going to try and give missing values their own category and their own color. And I don't want them, I don't want that, I want them to be gone entirely. So this is going to force the plot to ignore those NA values. I'm going to give a name to my color scale, cohesion. So this will help to label the legend. And I'm going to tell it what exact labels are supposed to go on there. Here comes that concatenate statement again. Low and high. So this is in the order that they appeared in the data. 0 was low, high was 1. Okay. Bring that parentheses over here. Okay. So that's the changes I've made to our existing set of commands. I don't see any errors. Let's see if that comes out right. Okay, looks pretty good. So now you can see I've got some green dots and some purple dots. And what becomes a little more clear here is that the green dots, so the high family cohesion, do seem to be a bit more concentrated in the lower levels of depression, and the purple dots are overrepresented in the higher levels of depression. I also want to overlay some means on there. I can use the exact same strategy that I had used before to make a single set of means for depression by age. In this case, I want two sets of means, right? I'm going to need means for low cohesion and means for high cohesion, and I can do that using the same set of commands that we implemented from the dplyr package. Again, I'm feeding the sim data into a grouping statement and a summarized statement. I'm also going to kick out the NA values, again trying to avoid them getting their own level here. So this says exclamation point is NA. So that means, okay, how does this read? So I'm filtering this data to exclude. So exclamation point means not in the context of this code. So not NA, not is NA, right? So none of the missing values from the variable in parentheses here. So filtering out the missing values from cobin, my family cohesion grouping variable. So once I've filtered those out, telling R to feed that data into the next line, which is again that group by statement. Okay, group by, last time we had age bin, but now we've got a second grouping level. So we need age bin and cobin, both of them. Feed that into a summarized statement. We're going to make mdep again. And mdep will be the mean of depression. Again, I don't think I need that NA remove statement here, but I'm going to include it just in case. And we'll see what happens when I run that command. Let's take a look at dep means 1 now. All right, so now a slightly longer data set where I've got 2 entries for age 12, right? Age 12, cobin 0, age 12, cobin 1, and so on, all the way through 30. Great. So I'm going to take that plot and add to it. In fact, let's do this a little bit differently. Instead of typing out that command again, we'll see what it looks like when we just take the existing plot and add on top of it. So 2 means is our new object containing our old plot grouped, remember? That is an object in R that I can use to enter as the contents to another object. So to means is going to be a new plot consisting of the existing plot grouped plus some additional information. In this case, it'll be geom line. And we are not inheriting any aesthetics. We're going to have to tell R to pull from this new data set that we created with the aesthetics y equals mdep, x equals hbin, and color, right, where we have a variable that indicates the lines are going to be different colors, and color equals factor cobin. Make that line size equals 1 again. Let's also do connect the dots, geom point, tell it which data set, tell it the aesthetics, and also have to tell this one the colors, and I made that size equals 2 last time. Okay. Nothing else changes, so I'm just literally adding these 2 lines to an existing plot. So if I run that, I get no errors, and if I ask it to render the new object, to means, here I go. So now I've got a couple of overlapping mean lines here. Okay. Again, 30 is included, so it looks like a bit of a dramatic shift upward. That isn't really accurate. But you can see over the kind of core period of adolescence, there's a pretty noticeable difference between young people coming from families with low cohesion. Their depression scores are on average higher, and the high cohesion families are a little lower. Okay, so those are a few ways that you can fit that you can make plots for raw data coming from a longitudinal data set. In the next video, we'll go through a few strategies for plotting your fitted data.